expand binomials to whatever degree. All right, so Pascal's triangle, that's the little trick that I'm going to show you and how it connects to the binomial theorem. All right, so I'm going to look at solving absolute value equations today, absolute value equations. All right, so one of the things I mentioned earlier in one of my videos when I first started doing these is how important it is to tell the truth when it's time to talk about certain mathematical concepts. Absolute value would be one of those times where the truth isn't always told in its entirety. Okay, so a lot of times when I ask, okay, what is an absolute value? Students give me the response and they say, it makes all numbers positive, which is true, but that's not what an absolute value is. See what I'm saying? Absolute value, that's one of the functions of it. That's what it can do, but that's not what it is. All right, so I want to first start off with that definition to make sure we understand truly what an absolute value is. So I hope you read that. In essence, absolute value is your distance from zero. That's it, your distance from zero. So if I said I was 10 spaces away from zero and I asked you what number am I, there's two possibilities, right? And this happens every time I ask this question. Some students will say, you're 10, and another student will say, you're negative 10. But guess what? Both of them are correct. All right. The reason why both of them are correct is because we're talking about absolute value now, the distance from zero. And remember, there's two sides of zero, a positive and a negative side. See, there's zero right there in the middle, zero right there in the middle. If I go 10 spaces that way, I'm at 10. If I go 10 spaces that way, I'm at negative 10. Therefore, if I'm 10 spaces from zero, I could either be a positive 10 or a negative 10. So what I'm about to do is show you the way we present that question in a mathematical form. And this is what I mean by this is how it's presented in a mathematical form. It's letting you know that I'm 10 spaces away from zero right here. This number lets you know how many spaces you are from zero. The question is, what number are you? Get what I'm saying? So when you see a problem presented this way, the absolute value of x is equal to 10. It basically wants to know what number is 10 spaces away from zero. That's it. But this time, if you think about it, it's not just a number that's 10 spaces away from zero. There's two numbers that's 10 spaces away from zero. So there's your solution. X could be equal to 10 or x could be equal to negative 10. And you have solved this equation. The key thing to remember here is that you have two cases to pay attention to now. All right, so I turned it up just a little bit. Now I have an absolute value of x minus 5 is equal to 10. Remember, we're talking about an absolute value. There are two cases that you have to take into consideration. And here we go. We have an x minus 5 is equal to 10, or we're going to have an x minus 5 is equal to a negative 10. So we solve both of these separately. This one is easy. You just plus 5 on both sides. I'm going to go ahead and show that step. So x is equal to, because those do strike out and give 0, 15. All right, that's 1. The other side, okay. We plus 5 on both sides here. Now, once again, that's 0, so x is equal to, and that's a subtraction. The signs are opposites of each other, and the answer there is negative 5. So we have two solutions. Either x can be a positive 15 or x can be a negative 5. All right, so here it is. I'm about to verify my work. I could verify it by plugging in the numbers and working it out, but I like to use graphs as much as possible. There will be times where students will start graphing, so I try to get them looking at graphs as soon as possible. So here we go. This V shape is the absolute value itself, all right? Anytime you graph something that becomes a V shape like this, symmetrical, probably looking at an absolute value. All right. Now, the 10. Remember, I said my absolute value was equal to 10. There's 10, and it's holding steady at 10. So when we find these solutions, the two that we have on the board, what we're trying to do is on the graph, we're trying to find out when does my absolute value equal my 10. and they're equal to 10 two times. It's equal to 10 here where they intersect, and it's equal to 10 again over here when it intersects again. So I'm going to use this to verify all of my numbers. Now, up here, I have my intersect function. If I touch the graph and I touch the line, it finds 2 points. One of the points is here, and it's going to find the other point over here. And that's the other point over there. So I'm going to check out and see what point A and point B says on the board. Look at that number. That's a -5. And look at that number. That's a 15. That should be the same -5 and 15 that we got here. So this is correct. So I'm showing an example, another example now. This time is going to be maybe 2 steps versus the 1 step that we just dealt with. Now notice right here, this is what I try to get you to get in the habit of once you understand how to solve these. The part that you see here is the one that you write twice. See that? The result that you get here, you put a positive on one side and you put a negative on the other side. That's how you set them up every single time. That's going to happen every single time. That's the one thing that's going to remain constant. No matter how difficult we make the problem look, you're writing that down twice and you're going to do a plus on one and a minus on the other. That's it. If you can do that much, then we can probably move forward to mastering this concept, or at least getting the steps and the procedure right. All right, so we're going to solve this one. That means we have to add 4 to this side. That's a 14. Bring down the 2x. All right. Then we got to divide 2 on both sides. So that's a 7, and that's an x. So we have x is equal to 7. That's one of them. All right, over here, same thing. I got to take this -4, add it to the other side. If I do a +4 here, that's going to give me a -6. So I can bring down the 2x. Now, if I divide both by 2, I'm going to get a -3. So x is equal to -3. There we go. We got 2 solutions here. I can verify it by hand, but I'm going to use technology to verify to save time. All right, so I'm using a Casio 9860 G2, FX 9860 G2. If you ever want to look into a calculator, get one of these, go on Amazon Prime. You can find them for under $100. All right, so it's already beating out the price of a Texas Instruments. Texas Instruments is still a good calculator, but I think this is easier to use and you get more bang for your buck. All right, so let's move forward. Here we go. Now right here, absolute value of 2x minus 4 is equal to 10. That means I had to write these down separately, and then I can look at them at the same time on the calculator. So boom, I have it. The V shape is the absolute value. This 10 is a horizontal line at 10. Remember, we have 2 solutions because we have 2 intersections. So we're going to look at the first intersection. Let's see. Intersect. There it is. X is equal to -3. On the board, I have x is equal to -3. All right, I'm going to move it over. Next intersection. X is equal to 7. On the board, I have x is equal to 7. That means what I did on the board was correct. I did find the solution because I just checked it. All right, so that's pretty much how it works. When you're doing absolute value equations, the part that's inside of the absolute value, like right here, the 2x minus 4, you write that part down twice. You're going to set it equal to the positive constant, and then you're going to set it equal to the negative constant. And that's pretty much how you set up those problems and then solve them separately.